Welcome back to the MathMind channel. In today's video, we're exploring a question from an entrance exam. I don't know how gifted you have to be admitted into this program, but I just know that it's a ton of fun. So, as always, feel free to test it out for yourself. Let's go ahead and get started. In the following question, we're given the equation of a cubed plus 2 square root 7a squared plus 7a plus square root 7 plus 1 equal to 0. And of course, we are going to be solving for a. When we explore this question, we notice that all the square root of 7 is creating a problem in terms of how we are going to solve this question. So we need to find a way to work around this square root of 7. We can do that by substituting it with an algebraic entity. Let's go ahead and call b equal to square root 7. From here, I can let 7 equal to b squared. Let's go ahead and rewrite this equation. When we rewrite this equation and replace square root of 7 with b, the equation becomes a cubed plus 2ba squared plus b squared a plus b plus 1 equals to 0. From here, I'm going to do some rearrangement, and I'm going to rewrite this whole thing as ab squared plus 2a squared b plus b plus a cubed plus 1 equal to 0. Let's take a moment to make sure that we did not leave anything out. I have a cubed, 2ba squared, b squared a, b, and 1. Everything seems to be in order, so let's move on. From here, I'm going to try to do some factorization. I have a b squared, and I'm going to take out the common term from these two, which is b. And if I do that, then this thing becomes 2a squared plus 1 bracket b plus a cubed plus 1 equals to 0. Let's take a moment to explore the left-hand side of this equation. I have a polynomial of b with the highest power being b squared followed by b followed by a constant term. In other words, this expression fits into the general pattern of ax squared plus bx plus c equal to 0. So we actually have a quadratic equation. And before we go any further, I want to point out that when we are solving quadratic equation in this channel, usually we do not consider imaginary number or complex number. I made a mistake of not pointing this out earlier, and a viewer commented on it, and that's entirely my fault. For that, I apologize. So let's go ahead and continue. Let's spend a moment to explore what I have in this green bracket. I can express this as a cubed plus 1 cube. And this being the sum of two cubes, I can express that as a plus 1 multiplied by a squared minus a plus 1. So let's go ahead and substitute this into our original equation. And now the equation becomes ab squared plus 2a squared plus 1 b plus a plus 1 a squared minus a plus 1, and of course that's equal to 0. We are going to attempt to solve this quadratic equation in terms of b, this being my a and this being my b and this being my constant term c. Is there an easier way to solve this quadratic equation? Let's go ahead and find out. The terms on this quadratic equation looks weirdly complicated. So before we even attempt to solve it, I'm going to give a simple example as a demonstration. Let's say I'm trying to solve the quadratic equation of 2x squared plus 13x plus 20 equal to 0. We can use what's called a cross multiplication method. So I have 1, 2, 4, 5. 2 times 4 is 8. 1 times 5 is 5. So that's 13. That's 20. That's 2. In other words, I can write this quadratic equation as x plus 4, 2x plus 5 equal to 0. From there I can solve for x. That's simple enough, but we are going to apply the same logic to try to solve this equation. So what I have now is 1a plus 1 a squared minus a plus 1. If I do a cross multiplication, this becomes a squared plus a, and this will be a squared minus a plus 1. If we work out the sum, that will become a squared plus a squared plus a minus a plus 1, which is equal to 2a squared plus 1. And that's exactly what I have as the coefficient of b. So we can now try to factorize this quadratic equation. From here, I'm going to rewrite our quadratic equation in its new form. So what I have now is b plus a plus 1 ba plus a squared minus a plus 1 equals to 0. Let's work each of them out separately. I have b plus a plus 1 equal to 0, and keep in mind b is equal to square root of 7 as we have stated earlier in the video. So let's go ahead and use this value for b. I have square root 7 plus 1 plus a equal to 0, meaning a is equals to the negative value of 1 plus square root 7. Let's consider our second scenario. I have ba plus a squared minus a plus 1 equal to 0. Let's rewrite this expression. I have a squared minus a plus ab plus 1 equal to 0. A squared plus ab minus a plus 1 equal to 0. Again, we have b equals to square root 7. So if we substitute this value of b, we now have a squared plus square root of 7a minus a plus 1 equal to 0. From here, I can rewrite that as a squared plus square root of 7 minus 1 multiplied by a plus 1 equal to 0. If we take a look at this quadratic equation and we express it in the form of ax squared plus bx plus c equal to 0, I have a equal to 1, b equal to square root 7 minus 1, and c equal to 1. Let's go ahead and work out the determinant of this quadratic equation by solving b squared minus 4ac 4ac. I'm trying to work out the value of b squared minus 4ac. So what I have is square root of 7 minus 1 square minus 4 multiplied by 1 multiplied by 1. From here, I have square root 7 square minus 2 times square root 7 times 1 plus 1 minus 4. So this works out to be 7 plus 1 minus 4 minus 2 square root 7. In other words, I have 8 minus 4, which is 4 minus 2 times square root of 7, and that's the value of our determinant. We can easily work out this value to be less than 0, meaning on this particular quadratic equation, there is no rational roots. So we are going to reject this as a possible solution. I want to emphasize again that for this channel, all the questions that we are dealing with only focuses on rational roots, and we are not dealing with complex numbers unless otherwise stated. So, based on this observation, we now know that the only answer to our original cubic equation is a is equals to negative 1 plus square root 7. And this is the answer to this very interesting question. Again, I thank you for taking the time to watch this video. Have a blessed day. Goodbye.